This video is meant to provide a brief overview of the most common types of interior lighting technologies found in federal buildings. The goal of the presentation is to provide a foundation for the language and concepts in this area. Light bulbs, or lamps as they are more commonly called in the lighting industry, can be characterized by a number of key features. We will start with the technology type and move on to some other defining elements. There are four common technology types for interior lighting. These are incandescent, halogen, CFL, and LED. Generally speaking, the cost increases progressively with the more efficient technology. However, LED and CFL lamps have seen drastic cost reductions in recent years and are often incentivized by utility rebate programs. Base type or connection type is another key distinction between lamps. This diagram shows a large number of connection types and can be very useful as a reference. But only a few of these bases show up commonly in federal buildings. These most common connection types are shown here. Starting in the upper left, we see the series of screw-type bases. Of these, the E26 is the most common and is what most people in the US use in their own homes. It is often called an Edison-type base. Another relatively common screw base is the E12 or candelabra. These are often found in restaurants and hotels and are commonly used with decorative lamps. To the right we have the twist and lock type bases. These two are used with spot or directional type lighting. This type of lighting would be found in auditorium spaces or any space where lighting is being used to highlight a person or object. We're going to skip over the specialty bases and bi-pin bases and look specifically at fluorescent pin bases. The two bases highlighted in this section are frequently used with fluorescent tube lighting. This lighting makes up the bulk of interior lighting in federal buildings. We will see example lamps for each of these bases in just a moment. One more relatively common connection type is shown here as the 2G7. It is often used with a specific compact fluorescent lamp that we will see on the next slide. However, LED lamps are made with this same base type and can be used as replacements. This slide shows example lamps for each of the bases we just discussed. Here we are focusing on the base type, not the technology. Starting in the upper left, we have the E26 or Edison type, then the E12 or candelabra, next the 2-pin connection found on the tube lamps. We should note that the spacing of these 2 pins depends on the lamp type, but we will go into greater detail on this spacing in a couple minutes. On the bottom left, we see the compact fluorescent with the 4-pin 2G7 base, and then the 2-spot or directional lamps. Now we can take a moment to talk about the color of light. You will often hear the term CCT when talking about the color of light. This stands for correlated color temperature and refers to the color of light that is correlated with radiation from an object at a given temperature. These terms, from warm light to daylight, are standard terms in the industry that are used to describe different portions of the CCT spectrum. Most incandescent and halogen lighting falls on the far left side of the spectrum, in the warm white and soft white regions, but compact fluorescent and LED lamps can be selected in any of the regions. Generally speaking, many people strongly dislike working in areas with lighting on either extreme of the CCT spectrum. Providing light in the 3500 to 4100 K region usually results in the highest overall satisfaction. Here we would like to make a couple brief comments on lamp dimmability. Dimmers are not found in many federal buildings, but the issues related to them merit a few moments for discussion. First of all, dimmers are lighting technology specific. This means that dimmers will usually need to be replaced when changing lamp technologies. Further, not all dimmers that are rated for a technology will work with every lamp of that same technology. Dimmer switch manufacturers provide lamp compatibility lists that can be checked before installation to provide greater confidence. Pairing incompatible dimmers and lamps can result in lamps buzzing, flickering, and premature lamp failure. Now let's take a minute to talk about the ratings you will see associated with lamps. A couple of the most important ratings are listed here. The lower two, UL and DLC, are provided for a better overall understanding of the language seen on lamp packaging. These two ratings specify the lamps have been tested and meet certain minimum requirements with regard to safety, light distribution, color, and longevity. The Energy Star rating is very similar to the DLC rating, but also includes efficacy or light efficiency. The ENERGY STAR rating is particularly important because lamps are often required to have this rating in order to qualify for the many utility incentive programs that can be found around the country. To the best of our knowledge, utility rebate programs are available in every state in the United States. However, most of the programs occur on a yearly cycle and may run out of funding partway through the year. You can find the utility program in your region by going to the Database of State Incentives for Renewables and Efficiency website shown here. Then click on your state or provide your zip code to find the list of relevant programs. Scan the list for items that show up as a rebate program and try to find the business or industrial program for your utility provider. We will be providing more information on this process in a future video. Let's take a look at some example rebates that are available. Standard LED lamps that qualify for the utility program cost about $4 each, while the incentives can range between $1 and $9 per lamp. This range depends on the region and the lamp technology that is being replaced. Further, these LED lamps are often directly incentivized at local retail stores such as Walmart and Home Depot, and cost less than $2 a lamp during these programs. The incentive programs also cover decorative lighting, spot lighting, and exterior lighting. As mentioned earlier, fluorescent tube lighting can be found frequently in federal buildings. You will commonly hear about T12, T8, and T5 fluorescent tubes. In this naming convention, the T stands for tubular, and the number denotes the diameter in eighths of an inch, as shown on the graphic on the right. A comparison of the T family of fluorescent and LED tube lamps is given in this table. There are a couple key points to take away from the table. First, notice that the pin spacing is the same for all the lamps other than T5. This is important when it comes to updating lighting because it means that the tombstone, the part of the fixture that holds the lamp, and shown in the upper right of the slide, must be replaced when converting to T5 lamps. This requires rewiring and can greatly increase the cost of the project. Next, we can see that the efficacy or lighting efficiency significantly improves from the older T12 technology to the more recent T5 and Super T8 lamps, but still underperform the LED tube lamps. Finally, when looking at the price per lamp, we can see that the LED tube lamps are the most expensive. However, these costs only reflect the lamp costs, which can be small when compared to the total install cost when rewiring is required. Additionally, LED tube lamps do not need an external ballast to operate. Fluorescent tube lamps do require a ballast for the fixture, and the whole fixture will not operate when the ballast fails. This can be an ideal time to replace a fixture with LED lamps, as removal of the ballast would be required in either case. The lifetime of the lamps is another important aspect to keep in mind when determining the overall cost of the lighting system. This lumen maintenance chart shows the expected lifetime for a number of lamp technologies. Most technologies experience catastrophic failure, but LED lamps usually fail through a gradual dimming process. A lamp is said to have failed when it drops below 70% of its rated lumen output. You can see from the chart that the expected lifetime for LED lamps is much longer than the rival technologies. This lifetime should be taken into account when comparing lamp costs and also associated labor for replacing lamps. There are a couple variations in LED tube lamps that should be pointed out. These variations can have a strong impact on the financial viability of your relamping project. The first distinction is between plug-and-play and direct wire types. The plug-and-play LED tube light can be used as a direct replacement for existing T12 and T8 fluorescent lamps, without any need for rewiring. They provide most of the benefits of LED lighting with very little cost or labor, but usually require newer instant start electronic ballasts, not the older magnetic ballasts, to function. A ballast checker can be used to determine if the right type of ballast is already present in the fixture, but due to the many variations in ballasts, the best option is often to just try a plug-and-play lamp before ordering a large quantity. A failure of the ballast at a later time will still result in a total failure of the fixture when using this type of LED lamp. The second option is for direct wire tube lamps. The ballast must be removed for these lamps, which adds cost, but also removes the potential for future failure of this component. There are two varieties of the direct wire type LED tube lamps. These are dual end powered and single end powered. While both of these cost about the same amount, the dual end powered variety requires much less wiring work and is therefore preferred. This concludes the building lighting overview. Please check the channel soon for upcoming videos on costing lighting projects, identifying your regional utility energy incentive programs and applying for project rebates, and LED tube installation with ballast bypass wiring.